Good evening everyone, welcome to Cambridge Guru. This is the second part of the further algebra topic. We have already done the introduction of general binomial expansion, in which the index of any binomial term is any real number apart from any integer, right? So let us do some more couple of questions based on general binomial expansions. So a question of the type that it says that the equivalent binomial expansion of a plus x raised to power n, where n is not a positive integer, is rather unwieldy. It is easier to start by taking a outside the brackets, right? So for example, if it is given that a plus x raised to power n, where a is any constant, so how you will do this is that you will take a raised to power n outside, and then you will write inside the bracket the expression as 1 plus x upon a raised to power n, right? So the illustration that is based on this you can say concept is this, that expand 2 plus x raised to power minus 3 as a series of ascending powers of x up to and including the terms in x square, stating the values of x for which the expansion is valid, right? So let us do this. Solution. Since value of a in this case is 2 plus x raised to power minus 3, so we will take 2 outside first. So we will write this 2 plus x raised to power minus 3 as taking 2 outside. Inside the bracket you will get 1 plus x over 2, right? And this is minus 3 and this is minus 3, right? 2 raised to power minus 3, 1 plus x upon 2 raised to power minus 3. Right, so basically what we have to expand is this is 1 by 8, right, into 1 plus x over 2 raised to power minus 3. Okay, this is equal to 1 by 8, 1 plus nx. We have to include till the term x square, right? So as the expansion is 1 plus nx plus n into n minus 1 upon 2 x raised to power 2, right? So till that term we will include the terms, means till x square, right? So this is 1 by 8. Inside the bracket I have 1 plus nx plus n into n minus 1 over 2 into x square, right? Till this term we have to expand, right? Now putting the value of n here, as we know that value of n is minus 3, and this x we will take as x over 2. Okay, it means that x is representing as x by 2, right, in this formula. So this will be 1 by 8, 1 plus n value is minus 3, so write this as minus 3, and in place of x, as I told you, it is x over 2, right, plus n is again minus 3 minus 1 over 2 into x square. What is x square? It is x over 2 whole square. Okay, bracket closed. Now it is just a matter of simplification. Simplifying this as 1 by 8, this is minus 3x by 2, so 1 minus 3x by 2, and this is minus 3 minus 4, which is plus 12. Plus 12 upon 2 is plus 6, and this is x square by 4. So basically it is plus 6x square by 4, right? Now again simplifying this as multiplying this 1 by 8 inside the bracket, this will give you 1 by 8 minus 3x over 16, and simplifying this as plus 3 by 2, so this will be 3x square by 16. Okay, so this is the expansion till the term this, and we have to write this as plus so on like this. Okay, we do not have to end like this, there must be some dot dot dot. We say these are ellipses. Okay, so 1 by 8 minus 3x by 16 plus 3x square by 16 is your expansion, and we have to state the values of x for which the expansion is valid. Now since we know that for the expansion to converge this, for this binomial expansion to be converged, this x by 2, whatever is x, its value should be less than 1. Value means the magnitude, So if you are talking about the magnitude, we have to take the modulus sign. Okay, so basically this x over 2, because instead of x we have x by 2, so modulus of x by 2 should be less than 1. That means modulus of x should be less than 2. So for all the values which are lying between 2 and minus 2, this expansion will converge or valid. Fine. Let us take another question of the type this. That now we have to find out the value of a and b such that 1 by 1 minus 2x and 1 plus 3x is approximately equal to a plus bx. So how we can do this is, because there will be some question in which the factors or the terms are in the denominator. So if the terms are in the denominator, how we can expand this? You just have to write this, means making these two terms in the numerator, or pulling these terms in the numerator by making the index as minus 1. So 1 upon 1 minus 2x into 1 plus 3x. Okay, this can be written as 1 minus 2x raised to power minus 1 into 1 plus 3x raised to power minus 1. Fine. Okay, now we have to expand this till a plus bx. A plus bx means till the term x only we have to expand this, and we do not need to include the higher order terms like x square or x cube. Okay, so what we can do is, here is that here the value of x is minus 2x, and here the value of x is plus 3x. Okay, and value of n in this case is minus 1 in both the brackets, right? So I'm just writing this in terms of 1 plus nx. So here I have 1 plus value of n is minus 1 and value of x is minus 2x. This is the expansion of the first bracket, and if I remove this, let me write this first dot dot dot. So this is the expansion for first bracket, and for the second bracket it is 1 plus nx, n value is minus 1 and value of x is 3x. Okay, I'm sorry again because this I always forgot to write this as dot dot dot. Okay, so 1 minus 1 into minus 2x is 1 plus 2x, and so on, into 1 minus 3x, and so on. If you multiply these two terms, you will get a constant term which is 1, and then total number of x will be plus 2x and minus 3x will be minus x, and then there will be a term which will be of higher order, and that will be minus 6 x square, and so on, right? And since it is saying that it is approximately equal to a plus bx, so it is writing this as approximately equal to a plus bx, means since x in this case could be very small, that's why it is of the term, means of all the higher terms will have some, you can say, negligible values. Okay, so we are just ignoring this, and it is saying that only the solution is valid for first two terms only. Okay, because other terms are very, very small. We can take the approximate solution till the second term, a plus bx, right? So we can ignore this minus 6x square, and now if you compare both the LHS, which is 1 minus x must be equal to a plus bx, so that means that value of a is plus 1 and value of b is minus 1. Okay, a is plus 1 and b is minus 1. Fine. Let us do one more question. It says that find the coefficient of x square in the expansion of 1 minus 3x upon under root of 4 minus x. Again, if any term is in the denominator, we have to bring that term in the numerator. Okay, so how we can do this is just by writing 4 minus x raised to power half as 4 minus x raised to power minus half. Okay, using the property that a raised to power n minus n is equal to 1 upon a raised to power n. Okay, so 1 minus 3x over 4 minus x square root, this is equal to 1 minus 3x into 4 minus x raised to power minus half, because half raised to power is square root, and if it is from the denominator we will write this as minus half, right? So it is 1 minus 3x. Now I am taking the expansion, but before that it is of the type a plus x raised to power n, so we have to take first a outside, right? So writing this 4 minus x raised to power minus half, taking 4 raised to power minus half outside like this, inside the bracket you will have 1 minus x by 4 raised to power minus half, because if you push this 4 raised to power minus half inside the bracket, that will be 4, okay, and minus x, yes, 4 minus x raised to power minus half. All right, so this is 4 raised to power minus half, means it is the square root of 4 and it is in the denominator, so basically it is written as half. Okay, so half 1 minus 3x into 1 minus x by 4 raised to power minus half, and we have to expand till or find the coefficient of x square. So at least till x square we have to expand this. Now let us expand this. This is 1 by 2, 1 minus 3x into, now value of n is minus half and x is minus x by 4. So I'm writing directly as 1 plus nx, putting the value of n as minus half. This is n, and value of x is minus x by 4. This is 1 plus nx, and till x square we have to expand this. So again n into n minus 1, so value of n is minus half, n minus 1 means minus half minus 1 upon 2 into x square, and what is x square? That will be minus x by 4 whole square, and so on. Okay, so this is the expansion for 1 minus x by 4 raised to power minus half. Now let us quickly simplify this. It is half 1 minus 3x into, this is plus x by 8, so 1 plus x over 8. Now be careful to simplify this. It is minus half minus 1 is minus 3 by 2. Minus 3 by 2 into minus 1 by 2 is plus 3 by 4, and in the denominator we have 2, so this is basically plus 3 by 8. Okay, and this is x square by 16. So here we have x square by 16 into 3 by 8, that means 3x square by 16 into 8 is 128, right? And all the signs are plus, so plus 3x square by I think 128. Okay, so this is the expansion for this, and obviously plus dot 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 like this. Okay, let me check it again. It is minus half, this is minus 3 by 2, it is plus 3 by 4, right? So plus 3 by 8, 8 into 16 is 128, and in the numerator we have 3, so it is 3x square by 128. Okay, I think it is right. Now we have to find out the coefficient of just x square. So we will get the coefficient of x square if we multiply this constant, this 1, with x square. You will get one constant, one coefficient, which is 3 by 128, and next coefficient will be obtained by multiplying this 3x term with the x term. So if you multiply x with x, you will get x square, and if you multiply a constant with x square, you will get the coefficient of x square, right? So we have this as half outside into coefficient. Now I am saying that this is plus 1 by 8, multiplying, not 1 by 8, I'm sorry. This is multiplying constant with this, it is 3 by 128, and multiplying this minus 3 with this, it is minus 3 by 8. Okay, this will be the coefficient of x square. So simplifying this, this is half, this is 16 into 8, so 16 into 3 is 48, 3 minus 48 is minus 45 over 128, because LCM of 8 and 128 I think it is 128 only. Okay, so it is minus 45 over 256. This is the coefficient of x square. Okay. So just go through all these 3 or 4 illustrations for this binomial expansion. All the varieties that can come in this part of the topic of, in this part of further algebra, that is binomial expansion, are only these. Okay. So that's all for binomial expansion. I hope I will see you in the next time, in the next video, which will be of partial fraction. Right. Last topic it is remaining in this further algebra, which is partial fraction. Okay, till then, take care. Bye bye. See you.